Okay, hello everyone. My name is Omkar Bhatt. I'm an engineering manager at Kasten by Veeam. So my topic today is about observability and ecosystem integration related to Kasten's K10. The agenda, I'm going to talk about how we use HashiCorp's Vault first for the purposes of encryption and decryption of keys used in Kasten. I'll show a demo for that. And then the next topic will be about how our users monitor backups captured by K10 using our integrations with open source projects Prometheus and Grafana. And I have a demo for that as well. So let's jump into the first topic. So for the purposes of protecting keys in K10, there are three methods that we support. The first one is an alphanumeric passphrase that a user can configure. The second one is Vault, and the third is AWS's key management service. I'm going to focus on just the two for the purposes of today's presentation and demos. But before I jump into more details about protecting keys itself, I'll give a little bit of background about how we encrypt backups today. So the box at the bottom is K10. When K10 is installed, one of our services that we deploy is called crypto service. And on the first install, it generates a master key. Now, imagine a user wants to protect an application that has MySQL deployed with it. This user is going to use K10's dashboard to create a policy to protect that application. Now, what the crypto service does is it uses the policy name and the master key to derive a unique key. And this unique key is the one that's going to be used for encrypting the contents of the backup. So for every policy, it's going to be a unique key. That's the goal here. And that's why we have this mechanism in place. So I'm not going to dive a lot into backup encryption. My focus is going to be on how we protect the master key itself. And that's where the passphrase and Vault integration comes in. So this is the first mechanism, the passphrase-based method. So over here, it's a four-step process depicted in the diagram. The first step is when the user installs K10, they're going to provide that passphrase. The second step here, we're showing the crypto service generates the master key. This is the first time K10 is installed. In the third step, the crypto service derives a key using this passphrase. And this derived key is the one that's going to be used to encrypt the master key, which is then stored in a database belonging to K10, which we call the catalog. So this is the encryption workflow with the passphrase. Now, why am I going to talk about the decryption workflow? So imagine the user wants to upgrade K10. Whenever you upgrade, it is going to cause a restart of all our services, including the crypto service. So you imagine it restarts, it doesn't have that master key generated anymore. So it has to go through this workflow of fetching it back. So again, 4 steps here. The service restarts. Step 2, it's going to fetch the encrypted key from our database. It's step 3, it's deriving a key using the original passphrase that the customer provided. That's a deterministic step. It's going to be the same derived key for a passphrase. And so that's why it's able to decrypt it and then store the master key back in memory. And then it goes back to doing backups as usual. So that's the passphrase-based workflow, and I will show how to configure passphrase-based keys, passkeys with K10 later. But in the next couple of slides, I'm going to talk about the Vault integration. So over here, when K10 is installed, we ask the user to provide the credentials needed by K10 to connect to Vault. We also ask for a key that's stored inside of Vault, which we're going to use. Second step, once again, the crypto service generates a master key. We ask Vault to encrypt it for us, and the encrypted key gets stored in the database. Now, going back again to the decryption workflow, in this case, there's a service restart. Step 2, we get the encrypted master key. Now, instead of deriving keys like in the passphrase workflow, we just directly go to Vault to ask us to decrypt that key for us. And then we cache the decrypted master key in the crypto service, and then backups go on as usual. Right. So I have a few CLI sessions here. Omkar 2 is, it's a GKE cluster. I don't have Kasten installed right now. So we're going to go through the steps to install Kasten, and I'll talk about the passphrases and Vault passkeys. So we're going to be using Helm to install Kasten. So first of all, let's create the namespace. This step is for adding the repository that contains Kasten's Helm chart. And then we're going to run a Helm repo update to fetch the latest chart that's published there at the repository. And then let's do a Helm install Kasten inside that Kasten.io namespace. All right, so what's happened as of now is Helm has installed deployments and TVCs in this namespace. I'm going to watch until the pods are ready before I proceed. So you'll see that it's pulling in the images in order to deploy all of our services. Now, while that's going on, what I'm going to do once Kasten is ready is I'm going to show you the API resources that are deployed when Kasten gets installed in a Kubernetes cluster. We have a bunch of them. Some of the APIs represent backup actions, there's export actions, restores, and imports. But for the purposes of today's demo, I'll be showing you that there's a passkey API that's installed by Kasten. Uh-oh. It'll take a little more time. We're almost there, making progress. Let me show you, while we wait for that, what the API looks like. So here's an example. This is the YAML file that defines a passkey. The API version says it's vaultkio.kasten.io. That's one of the APIs that gets deployed in the cluster. The kind says passkey, so that's the name of it's the type, the resource type. It's got some metadata and it's got a specification. So this is where the user registers intent, just like any other Kubernetes resource. But keep in mind that this is not a CRD, it's an aggregated API. So there are two types of resources available in Kubernetes. Let's see if this is ready. Okay. Okay, that's good. So I think we're ready.
Quick question. Where is the type of encryption being specified there? You know, there was three options there.
Yeah, so
is that a more global setting across the cluster or the whole install or?
yeah, good question. So in this case, I haven't defined what type, and by default, we fall back to the passphrase method. And so when I run the command to list the passkeys, you'll see that there's an automatically generated passphrase, because in this case, as a user, I haven't provided any passphrase to begin with. So you'll see here, I'm going to list passkeys, and hey, there's already one automatically generated for me.
Okay.
So we have fallen back to the passphrase method, but you could always opt to use Vault right from the get-go. And that happens by providing a value. Helm offers a values file where you can say that I want to start with Vault. So this passkey is named Kasten master key. It was automatically generated. Let's inspect the contents of this passkey. So you'll see again the API version that I was talking about earlier. And it has the status that says in use equal to true, meaning it's the actively used passkey in this cluster for Kasten. Before I proceed, I want to show the various APIs that are installed in the cluster when you install Kasten. So you'll see a bunch of them here. I mentioned backup actions, export actions, lots of other APIs. And the one that I'm interested for this demo is the passkeys resource, which is part of Vault.ko Kasten.io. So when a passkey is generated, I mentioned that there's a passphrase. So the passphrase is also automatically generated. We're going to inspect the contents of a secret that was created by Kasten, which contains that random passphrase. So here's the passphrase here. It's automatically created. The next step is to create a custom passphrase-based passkey. So this time, once I do that, when I list the passkeys, you'll see two of them show up. So the first step here is to create a Kubernetes secret. And we're going to say from literal. And this is where I'm going to specify my custom passphrase instead of depending on the automatically generated one that Kasten made. All right, so the secret is ready. And this is the YAML file that I'm going to use for creating a custom passkey based off of this Kubernetes secret. That was successful. Let's list the passkeys. You'll see the new one show up. And notice that because I had configured use now to true, when I inspect the contents of this new passkey, it's going to change to this new passkey as the actively used one in this cluster. And if I go back to the original passkey and look at its content, it should not say in use to true this time because I've switched passkeys. So as I said, it's not in use anymore. All right, so at this point, we have two passkeys. We had an automatically generated one and I have a custom one. So my next step is to now to show you how we can install Vault in this cluster and then upgrade Kasten so that it can start talking to Vault. And then I'll show you how to create a third passkey, which is going to use Vault. Oh yeah, so before I missed one step. So I want to show you the contents of the database inside Kasten that contains these encrypted artifacts. So let's do that, and then we'll move on to Vault. Let's create the namespace where we want to run Vault. Now we're going to use Helm again to install Vault. This is the repository where we're going to find the Helm chart meant for installing this. All right, so, and this is a values file that I'm going to use while installing Vault. What this is saying here is I want to enable developer mode, and the token that Kasten will use to connect to Vault is just a simple token root right now in dev mode. Obviously in production, it's going to be a token that's generated, but this is just for the demo. So let's use this values file to install Vault. Okay, so we're going to wait for the pods to be ready. Once they're ready, I'm going to run these commands that I'm highlighting here on the top. What these commands are doing is it's enabling the secrets engine in Vault. And the second command is going to help us add a key into Vault, which is going to be used by Kasten later. That's good. It says the secrets engine is enabled.
So it's the intention for this to create yourself a process in which you can actually encrypt your backups. And if that's the case, how do you sustain the encryption keys past the lifetime of the cluster?
So again, this particular key that I just created in Vault is not for backing up, not for encrypting the backup itself.
Right.
It's only for encrypting the master key. And the master key is going to be active in the lifetime of Kasten while it's installed in a cluster. If you were to reinstall Kasten completely, like let's say you deleted it and reinstalled, it's going to be a new master key.
Okay, I'm just trying to sort of understand. You know, as we're going through it, where we're getting to. I'm not entirely sure about where we're ending up with the demo.
Oh yeah, sure. So it's.
I may have misunderstood it or not been listening. That's all possible.
No worries. The intention was the initial slide was just to give a bit of background about how backup encryption works. That's going to be the same irrespective of the modes that I'm talking about, whether it's Passphrases, whether it's Vault or AWS.
But you said you're not encrypting the backup. You said though.
No, not encrypting it using Vault or KMS. The master key that's generated by Kasten is the one that's used to encrypt the backups eventually.
Oh, okay, so it is that then. Okay.
It is the master key, but the master key is not generated by Vault. It's not maintained in AWS.
Okay, so
where is Vault and AWS TMS playing a role?
Yeah, so once a master key is generated by Kasten, we need that artifact to be stored securely somewhere.
Okay, so we're storing it in Vault or KMS.
We are only using Vault or KMS to encrypt that artifact, but it's eventually stored in Kasten's own database. So it's just the part where you want to call an API to encrypt something for me or decrypt something for me. That service is offered by Vault or KMS.
Okay.
And that service can either live in the same cluster or it can be living outside of the cluster.
Obviously, it'd be living outside of the cluster.
Yeah.
KMS.
You obviously put that into the same cluster for demo purposes.
Just for demo purposes.
But the two key approach,
Yeah.
we need that master key,
Yeah.
and to then gain access, we need that other key.
but it just seems, obviously it's the demo side, but that is the bit that was getting confusing because it seemed a bit silly to leave your keys into the cluster that you could delete and then not have the keys to go back and get anything back out again. If the cluster's lost.
If you've lost, of course, yeah,
Okay.
yeah,
Fair enough.
just
Got
for
it.
demo purposes, yes.
And this is actually a mechanism called envelope encryption. And so you can use multiple keys to encrypt the master key and store those keys in different places. So you could have one in the cluster, you could have one outside the cluster as well.
So this allows me to use SaaS services for key management and not have to worry about someone getting access to the SaaS service and having access to my data because I have ultimately the master key, which is stored separately from
That's
Exactly right.
Yeah,
the SaaS service. Okay.
yeah. They don't have to remember a passphrase, like I said in the passphrase method. It's the user has to consciously generate one that's good enough and then maintain that in a secret. So they don't have to do that by using Vault or KMS. So now that we have Vault set up for us, we're going to upgrade Kasten so that it can talk to Vault. We're going to create a secret. In the Kasten IO namespace. So I'll show you the contents of that secret. So it's right there on top over here. The name of that secret is Vault Creds. The contents of this secret is this base64 encoded string, which is nothing but the encoding of the word root. That's the token that Kasten will use to interact with Vault. So let's go ahead and upgrade Kasten. All right, so here you'll see that this is the values file that I'm going to use to upgrade Kasten. And I'm going to paste in some details here. The first one is the Vault secret name that contains the credentials to talk to Vault. And the second one is the address where Vault, the service, is going to be available. In this case, I've used vault.vault.svc. That's a naming convention within the Kubernetes cluster where you can access a service deployed in the cluster using the namespace name and the service name.
Is any of that configuration available within the Kasten web interface?
The configuration of passkeys is not there today. It's all via API and CLI. But you bring up a good point. Yeah, we can definitely provide a dashboard to deploy passkeys. We don't have that today. While we wait for the pods to come up, here's a passkey that I'm going to deploy next once Kasten is ready. Once again, it's the same API version that we talked about earlier, Vault Kasten IO. It's a new name for the passkey called Vault-passkey. Now notice that instead of pointing it to a secret that contains a passphrase, I'm pointing it to a vault key and a vault transit path. Much faster this time, it's all upgraded. Let's go ahead and create the new passkey. That was successful, and the fact that it's successful is confirmation for me, because I know that the crypto service is contacting the vault service to verify that the configured key actually exists before it can successfully create our passkey. So things are looking good here. The connectivity was fine. Now let's list the passkeys. We've got 3 of them this time. The latest one is vault-passkey. And this is the one that's set with in use equal to true. So from this point onwards, the master key is going to be encrypted only through Vault. And that stays as long as the user does not switch to other passkeys. But they can always switch to other passkeys. So that's everything I had for talking about Vault and how we encrypt and decrypt our master key. Okay, so for this part of the presentation, I'm going to be talking about some of the metrics that we've added as of the 4.5 release for the purposes of monitoring backups, exports, and other actions taken inside of K10. I'll also show you a default Grafana dashboard that gets shipped with K10. And we'll also walk through the steps for how to create an alert using Grafana to get a notification on Slack. So that's the agenda for this part of the demo. So before the 4.5 release, along with all the other services that we deploy, we used to have just Prometheus at the bottom left here. We were already publishing various metrics, but with the 4.5 release, we started installing Grafana by default as well. All right, so for this part of the demo, I have a separate cluster, Onkar1, which is again a GKE cluster. I have a very simple application deployed in a namespace called time logger. It's just logging time into a file that's stored in a PVC. So here's the contents of the YAML file that I used while deploying this time logger application. It deploys a persistent volume claim of size 1 GB. There's a deployment. And this deployment specification has references to 2 containers. The one that we're interested in is here. And this is just logging the timestamp into a file. So I've already run kubectl create-f with that file, which is why you see the pods already running. The PVC is already deployed there. The PVC is there. All right, so now let's go to the dashboard. This is my ingress that's meant for accessing K10's dashboard. So we have Okta-based authentication enabled for K10 on this cluster. So I'm going to use my Okta creds. All right, so K10's dashboard shows applications discovered on the left. There's a policy section that's meant for creating policies to back up those apps. I have one policy created here for the time logger app. to back it up hourly and to export it to an S3 bucket in the US West 2 region. And I'm going to focus on the usage and reports section for most of this part of the presentation. So with the 4.5 release, we started shipping this link that takes you to the Grafana dashboard. And so on this default dashboard, you'll see that we have metrics for the number of actions that have either completed, failed, or skipped. And when I say actions, I'm talking about backups, restores, imports, and exports. We also have a section for cluster level backups and cluster level resources. We also have a section for the number of runs, policy runs that have happened on this cluster. So the next step is to show you how to create an alert. So let's take the number of backup actions that have started as an example and create an alert for it. So I have my Slack channel ready here. You can already see some notifications that were posted there from my previous tests. In order to make this work, we need a webhook that can be generated using Slack for a particular channel. And Grafana provides the option of creating a notification channel. We're going to select the type as Slack. And then under optional settings, you can paste in the web URL, the webhook URL. Let's select settings as default and save this. The nice feature over here is you can quickly test this instead of waiting for an alert to be triggered. So I've already clicked on test. And so you'll see that there's a test notification sent as a result of that operation. Next, we'll create a new dashboard. All right, so in this section where you get to create a dashboard, there are two sections that need to be configured. One is a query, and the other is an alert. Now for the query, my data source is the Prometheus instance of Kasten running in Kasten's namespace. I'm going to give this query a name. And there's a metrics browser here that lets you search by keyword. So I'm going to search for action backup started. And so you'll see that the time series got populated because I've selected my metric. We have 8 backup actions that were started in this time period. So our query is ready now. The next step is to create an alert based off of this query. Let's give the alert a name. And there are some parts of this configuration that are interesting here. So you'll see there's a section that says evaluate every X minutes. So that's how frequently this alert is going to be evaluated. And what the for 5 minutes means here is, suppose the threshold that was configured here is triggered, Grafana is going to wait for 5 minutes before it actually throws that alert onto Slack. And so this is customizable. In this case, it's a counter that's always going to increase. So it may not make a lot of sense here, but imagine if it's a gauge that's going up and down. If the state did not remain for 5 minutes, then you wouldn't get an alert.
Does this just do real-time data, or does it do historical data as well for trending?
So this is data that's generated on the cluster. One thing to note is there is a lag between the data being generated in K10 and it showing up in Prometheus. And that depends on the scrape interval that you configured. In this case, it's a 1 minute scrape interval. So Prometheus wakes up every minute and fetches the latest counters from K10. So you could see that lag, but I'm not sure what are you referring to when you say historical data?
Is there a database that stores previous data?
Right.
Can you look through yesterday's data?
Oh yeah, yes. So Prometheus is installed as a stateful service here. So that is a database, but there is a limit to how much data, historical data you can store. And we have a configuration that sets up pruning of this data at regular intervals. So I don't remember what that is off the top of my head, but
by default, it's 30 days.
30 days.
And so we actually have a lot of customers who will federate their Prometheus instances. Usually they'll have maybe either one big one that they run internally. And so we treat ours kind of essentially like a 30-day cache that they can then go add the rest of the data into. So we recommend that for aggregation.
To get enough information for your backup, is 30-day enough? I mean,
a lot of
this is a simple demo, but actually, if I look at, for example, at Veeam, I can have 1 year or maybe more of backup history, and usually to analyze trends, what is happening, etc. That's what I do. So 30 days is very limited anyway.
The 30 days is intended to be operational, I think, more than giving you data for analytics. But people have definitely used federation to then go aggregate all this data. It's especially important if you have many, many clusters because you need a central place to aggregate the data to anyway. This Prometheus and Grafana instance are actually deployed by default alongside the K10 instance. And so you have to figure out a way to aggregate that data regardless of the time period. And so I think the customers have used federation as a mechanism for both aggregation as well as longer term analytics.
And I think that was going to be sort of, to a degree, my point, Enrico, not necessarily the time side of it, but all that additional configuration work you've added on as we've been doing this, whether that's something you'd be doing all the time. But if it is deployed to every individual cluster, then potentially you would do that. So how much of that is importable, like what you've just shown us in this last bit, and how much would you be doing on every cluster install?
Some of this configuration can be posted into a config map. So when you install, you could have all of this just installed by default. We don't do that today by default, but the dashboard is, for example, I showed you the dashboard with the metrics. That's something we ship by default. You could imagine having the alerts also installed by default. We just don't do it yet.
Yeah, I guess what I'm trying to get to is just that if you were building a cluster and you'd almost have like your standard build, which would include all of the additional pieces that you're configuring, so that not only are you're doing the installation piece, you're doing all the post-configuration pieces as part of that as well.
Yeah, that's a great point. Yeah.
So it can kind of be done using like the Helm Terraform provider to deploy Kasten K10 repeatably exactly the same way. And then if you wanted to just deploy Prometheus, as to Tom's point, or Grafana to Tom's point, like have a global copy of that, and you specify what that setting looks like as part of that. I'm using Terraform as an example, but really it could be as simple as any other like infrastructure as code type deployment.
But in this model, you're not doing that. You're just doing
it manually.
Yeah.
I mean, aren't you going to forward your events and your performance statistics to some other central tool that's also watching other domains like network and you've got other things going on? I mean, this is really if you're just looking at Kasten, right?
Yeah, and I think the whole point of key management system, we're not going to go and develop our own. We're going to integrate into the ecosystem. Grafana, from a visibility point of view, we're going to hook into this. Datadog is another one, where goes to your point. The whole point of this is the extensibility of us being able to push that data out, and also from that, we're setting it once, but then it's done for the lifespan of that. But if you've got 100 clusters, 100%.
And that's just understanding, what you're demoing and what best practice might be. That's just trying to understand the two, really.
Yeah.
And I just opened.
Anyway, this is, I mean, for what I got, it's very complex, scenario. So in the sense that you have to configure a lot of stuff to have very limited, set of information that you can use for, planning your backup strategy and everything.
So I think that's fair as well from a 4.5 release, which is when we implemented the Grafana piece. So all the data's there from a Prometheus metrics. Like we're going to be constantly evolving what that looks like and what information that gives and what hooks are pushed into that to make it easier. Like Anka's going through the steps, but yeah, like it's how do we simplify that to get it up and running?
Okay.
Is that data currently available via Snmp? Have you any MIBs?
Everything would be from a Grafana point of view. I've not really played around with Grafana, so I don't know if there's a Snmp traps inside.
I'm not sure of that one. I'll have to check on that.
So I guess this is the challenge of working with Kubernetes and other open source projects. You want to do it in a compliant way. You kind of have to wait on the community. And if you kind of go faster than what the community does, then you risk doing it in a proprietary way. There's kind of a catch-22.
Yeah, exactly that.
Well said, thank you.
Okay, so I talked about some of the configurations on the top here. The next one is the condition when we want the alert to be triggered. So over here, I'm going to select the query that I've previously configured. And the 5 minutes comma now indicates that it's going to fetch data from now till 5 minutes ago in order to evaluate when do I send this trigger to Slack, this alert to Slack. I'm going to set the threshold to be 8. So the moment I trigger a backup from the dashboard, it's going to cross this threshold and we'll see an alert show up. So you'll see the notification section is configured to send it to the Slack channel. Let's just put in a custom message there and save this dashboard. All right, so the last thing to do here is to go to the policy and trigger a manual run. And while we wait for that, what I found interesting was that on this cluster, overnight I did notice some backups failed. So that actually prompted me to go look at my cluster and see what happened to my application. So I listed the pods in my namespace, and I noticed that there was a termination at some point 8 hours ago, which caused Kubernetes to redeploy my application, and that happened 8 hours ago. But since we were in transition at some point 8 hours ago, some of the backups failed here, and you'll see that in the policy runs. But since the application is up and running right now, I'm expecting it to pass. So we should see it succeed now, and then have the counter generated, the metric pushed to Prometheus, or rather scraped by Prometheus, and then that should lead to an alert.
While that's running as well, Craig, so I just look, it doesn't look like there's Snmp notifications, but there's a long list of like various different, I think Anka's using a webhook, but like OpsGenie, PagerDuty, like there's a long list of what they are. Obviously Anka's also showing Slack. So, but no, there's no Snmp on there. Obviously that's a Grafana piece. We're just hooking into that rather than us having to build out our own. Because I think it's fair, like, so most of you, again, familiar with, from a Veeam point of view, we went and built Veeam 1 management pack, right? And we could then manipulate that to whatever it needed to be. In the cloud native space, people are already doing that. And it's about us staying in that swim lane so that we make data management what it needs to be.
But I would stay tuned.
think I hit the same error as last night. So it's probably not going to.
If the pod is terminated, the back won't be able to back up the terminated pod.
Yeah, so I went ahead and deleted the terminated pod. And I think the next retry is going to succeed.
Yeah.
Okay, that did succeed. So that's good.
Live demo.
Live demo. So now we might not see it immediately again as a reminder because Prometheus is scraping this every 1 minute. So we haven't seen it gone up from 17 yet.
Scroll down in that dashboard while we're waiting for that. That gives it. I always think this, but the throughput and stuff on the Grafana dashboard. Like we're just showing the big widgets that say successful, bad backups, etc. Down the bottom though, we've got the like throughput, what's happening, how are we moving that, what's the catalog look like, what does the actual system look like as well?
How would that look on a multi-dashboard, or wouldn't it? Would you aggregate that, or would you still have separate instances to go and look at?
Yeah, that's a great question, actually. On our multi-cluster dashboard today, the primary actually is configured to scrape metrics from each secondary. So we do aggregate that and display it on the primary's dashboard. And that will keep evolving too. We'll
that makes that dashboard a bit more interesting when there's more data in it, doesn't it then?
Yep, absolutely. And the cluster name would be another dimension to that data. I think we're running out of time and I'll switch over to Tom, but the alert is going to basically look like this. You're going to see the custom message that I added in the alert, along with the metric that caused it, along with some useful labels. And this is the average that was calculated as part of the condition that I configured inside the alert.